In this video, we'll be looking at Chapter 8, Section H on box and whisker plots. Remember from our previous video that we were looking at the measures of spread and that we were trying to find these descriptive statistics for a data set. So we had the minimum and the maximum, which allowed us to find the range of the data set. We had the median, which is the value that splits the data set in half, and we had the lower quartile and the upper quartile, which split the data again into quarters. So a box and whisker plot is simply a visualization of these statistical values. And sometimes this box and whisker is just abbreviated to a box plot. And an example looks something like this. So the box of the box and whisker you can see is in the middle, and this really represents the middle 50% of the data set. And which we know from our previous video is the interquartile range. The whiskers show us the upper and lower quarters or quartiles of the data set. So let's take a closer look at the box and whisker plot. We see on the very left end we have a dot, and that represents the minimum value. The line that connects that dot to the box is the lower whisker. And the length of this line, or this whisker, represents the lower quartile of the data set, or the lower 25%. Likewise, we have a dot on all the way to the right of the box and whisker plot, which represents the maximum value of the data set. And that whisker represents the upper 25% of the data. The line in the middle is the median, which we can abbreviate as Q2. And that splits the data in half. The left-hand box is the spread between the median and the lower quartile, and the right-hand box is the spread between the median and the upper quartile, which are represented by these lines. We have Q1 here and Q3 here. And we use a number line underneath all of it so that we can plot it accordingly. And this is really just a quick visualization of these 5 statistical values. And these 5 numbers are often summed together and called the 5-number summary, which really is measuring the spread of the data set. Let's take a look at an example of how to draw a box plot. So in this example, we're given a data set. We're asked to find the 5-number summary and to draw a box plot. And then we're going to find the range, the interquartile range, and the percentage of data values less than 4. So just like in previous problems, we're going to order the data set first. We can see that we have 16 values. And so the median is going to be the average of the 2 middle numbers. So the data set is split right here. So the median is going to be 5. The lower quartile is then the average between the middle 2 numbers here, because remember I have an even number of data points. I have 8. So I need to take the average of the middle 2 numbers in the lower half of the data. So Q1 is equal to 3.5. Likewise, I'm going to take the average of the middle 2 numbers in the upper half of the data. So Q3 is equal to 6. And I know that the minimum value is 1. And the max is 11. And this is my 5-number summary. So let's draw a box plot. And the first thing I'm going to do is draw a line, a number line, and then I'm going to label it. Now to draw the box plot, I'm first going to put a dot at the minimum, which is 1, and another dot at the maximum. And then I'm going to draw a line at Q1, which is 3.5, and a line at 6, which represents Q3. And I'll draw another line at 5, which represents the median, and I'm going to connect those lines like so to form a box. And then the last thing I need to do is draw the whiskers, which are the lines from the minimum to the box and the maximum to the box. And this is my box and whisker plot, which is a quick visualization of the spread of the data set. Now I can find the range quickly. Again, it's just the maximum minus the minimum. So I have 11 minus 1, and I get a range of 10. The interquartile range is Q3 minus Q1, so I have 6 minus 3.5, so my IQR is 2.5. And then the last question asks us to find the percentage of data values less than 4. Well, I can see that there are 4 data values that are less than 4. So 4 divided by 16 is 25%. I have 25% of the data is less than 4, and I can see that from our box and whisker plot. I know that this whisker represents the lower 25% of the data, and those numbers are less than 4. Let's take a look at another example. In this example, we have an office worker who has a choice of traveling to work by car or by bus, and he's collected data on the time that it takes for each of those methods of transportation. And we can use parallel box plots here to compare the two data sets visually. In other words, on the same number line, we can put two box plots. And we've seen how to prepare those box plots, so I'm not going to spend the time to do that. But here's an example of a parallel box plot. Now, a few things here. Notice that we have 2 box plots on the same number line, which allows me to quickly compare a lot of things, including the median and the spread of the data. Also notice that with the bus, there are 2 asterisks here. And these asterisks represent the outliers of the data set for the bus time. So if you notice, we have a value of 30 and a value of 28, which are the last two bus travel times in the data set. And they're considered to be outliers, so we do not include them in the box plot of the bus times. So if we want to compare two things, the speed of each method and the reliability of each method, we can look at 2 different statistics. So to compare the speed, we'll look at the medians. And we see that for the bus, the median is 18 minutes. And for the car, the median is 22 minutes. And again, the medians are represented by the middle lines in the box. So, according to this data, the bus is faster. But what about the reliability? Well, reliability we can measure using the spread of the data. And instead of using we can use 2 different methods for the spread. One being the range, and one being the interquartile range, or IQR. And we see from the data, again, the range is max minus the min. We see from the data that the bus has a range of 14 minutes, whereas the car has a range of 30 minutes. And the interquartile range for the bus is 10 minutes, and the interquartile range for the car is 4 minutes. I'm sorry, I have those backwards. It's 4 for the bus and 10 for the car. So looking at the spread of the data, we see that the bus is less spread out. The data is less spread out. It's more reliable. So again, we can see from the data that the bus is the better choice.